All right, let's review the guessing game. So I know Ankur kind of reviewed it yesterday. I know some of you all had a difficult time determining like what attributes, instance variables, instance methods to use. But let's go ahead and kind of review it. And we'll do this using test-driven development just so you all can continue seeing TDD being written and implemented. All right, so let's go ahead. Am I sharing my screen? Yep. Can you all see my screen? The screen? All right, great. So I'm going to fork this over to my personal GitHub, which I already forked it over. So I forked it over Tom Preet guessing game. Let's fork that, or let's go ahead and clone that down by clicking the green code button, clicking this little check bar. So it's copied to the clipboard. And I'm in Papa Challenges. I don't see guessing game in there. So I'm going to do git clone OOP guessing game. I've got guessing game right there. And I'm going to CD into OOP guessing game. I'm going to open this up into a new VS Code window, and we'll go ahead and get started. All right, great. So I've got this guessing game class. I'm going to just put pass right there. And I don't have a spec file. It wasn't a requirement to create a test-driven development for this, but let's just go ahead and do it just so you all can see what that looks like. So I'm going to create a new file. I can either do it in the terminal or clicking this little plus new file. I'm going to just call it guessing game spec.py, and it opened that up into my VS Code, and I split the window. So I have the guessing game class, and I've got this spec file. So in order to write unit tests in Python, I'm going to import the unit testing module or library, and I'm going to also import the guessing game class into my spec file. So I'm going to say from guessing game, import the guessing game class. Whoa. All right. So to write a test suite for my guessing game, the first thing I'm going to do is actually create a class called guessing game test case, which is going to inherit from the unit test case class. All right. So you have some experience importing functions and methods and utilizing TDD specifically for functions and methods, but we haven't yet talked about using TDD or writing unit tests using classes. So it's very similar to just invoking functions. It's just you're going to have to create an instance of this game, the guessing game class, and then just call any methods or instance variables of that instance. So let's take a look at what this game requires us to do. Implement a basic Python class. Okay. All right. Your guessing game class should be initialized with an integer. So it should be initialized with an integer called something like answer or answer number. Okay. Define an instance method guessing game. So an instance method called guess. Hashtags and documentation means method. So the guess, which takes an integer called user guess as its input, guess should return a string. So it should return a string called high if the user guess is larger than the answer, correct if the user guess is equal to the answer, and low if the user guess is lower than the answer. Define an instance method called solve, which returns true if the most recent user guess was correct and false otherwise. All right. So I'm going to write def test user guesses high, which takes in a self. And so I'm just going to add. So when a user guesses 20, it should return. So user guesses high. So I'm just going to say when the user guesses 20, it should return. Actually, let's low. So I'm going to user guesses high. I'm going to do user guesses low. And self dot assert equal. All right, and then this part is like, all right, how do I instantiate a new? I'm going to say like game equals guessing game. And so if a user guesses low, so I'm going to just say the answer is going to be 40. So that's what the user needs to guess. So if I do game dot guess and the user guesses 20, it should return a string low. Like that. And then I can do the same with high. So user guesses high. So what's higher than 40? So I can say user guesses 60 should return high. So same, instantiate a new user game with the input of 40 and a user guesses 60, it should return a string of high. And I can test if the user guesses correct. What should it say? What should it return? Just the string correct. All right. So user guesses 40, not high, like user should return correct. So if the user guesses 40 and that input is 40, so this is what the user needs to guess, and the user actually guessed 40, that it should return correct. Questions about that initially? So I could streamline this. Notice how there's repeated code on line 10, 17, and 24. So I'm essentially instantiating a new game for each unit test. But if I go to unit test Python, here's this unit test. If you read through the documentation, so I've got test upper, test is lower. Let's keep going. Do I have anything? So I notice I have this test can be numerous and their setup can be repetitive. Luckily, we can factor out setup code by implementing a method called setup. So setup is a built-in method within the unit test framework that will be automatically called for every single test we run. So before every single test we run, if we have this setup method called like so you can see like an example, I have a setup method. I'm creating a new instance of this widget. And now I can access this instance of this widget and self.widget. Again, self is an instance variable. So now I have access to the self.widget everywhere within this class. So self.widget, self.widget. So I can do that up here. I can do def setup. That takes in just the self keyword. And I can do self.game. Again, this is an instance variable. I'm going to call it guessing game. I'm going to pass in 40. Now I have access to this instance of this guessing game inside of this inside of each instance method. So I can get rid of these three things. And now I've got this game, but I can access this instance of the game by doing self.game.guess. Questions about that. So this is automatically called before each unit test. All right. And then again, don't forget down here, I need to have that this if main equals unit test main. I'm just going to copy that down here. Don't forget that. A lot of people forget that, and that's where a lot of people's issues are. All right. I can also add, because in the here, I've got some other things. Guessing game solved. So I can test for the solved as well. I'm just going to do that right here. Solved. That doesn't take in any false. And now I can. So I'm just doing double right here. You can separate this into its own unit test, but I'm just going to put it into here just for ease of use purposes. So if it guesses high, it should return a string high. And if I call the solved method, it should be false because I haven't solved it yet. If I do guess the correct answer, it should return a string. When I invoke the guess method and pass in 40, it should return a string of correct. And then it should also, the solved function should return a string of true, or a Boolean of true. Questions about that? All right. So now if I run that Python guessing game spec, I get 3 tests that are failed. There we go.
Wait, Tom, can you explain the second line, the self assert equal self game solved false?
This part?
Yeah, that line for all of them.
Yep. So the guessing game. So if you look at the requirements, so guessing take the guess method, but it also here define an instance method called solved, which returns true if the most recent user guess was correct. Otherwise, it'll be false. So right here, here's an example. Game solved should return false. Game solved should return true. So if the user guesses, so the number that we want to try to guess is 40, we're passing in 40 in here. And when the user guesses 20, so the user guess is 20, solved should return false because we haven't solved it yet, because we guessed low. Does that make sense? Or no?
So I get why it's returning true or false. I just don't get how that's beneficial to us. I mean, isn't it if it's not correct, it's just not correct? And we already know if it's true or false.
Well, we just want to make sure that the requirements of our class have been met. So we need to have a solved method in here. A solved instance method. So I'm just checking to make sure that we have a solved instance method and it does in fact return a Boolean value.
So that second function is just checking whether the first one is correct.
Yep.
Okay.
It becomes important when you look at the driver code and what your coding partner has generated that needs to accept your code, then all of a sudden it becomes important.
Yep. All right, so we can either use this driver code or this code. It doesn't really matter. I'm just going to use this. Well, I'm not even going to use this. I'm just going to use this, the TDD, these test cases, as my I mean, I can keep on building upon this, but I'm just going to use this to make sure that everything works correctly. And I'm also going to read the requirements. So your user guess should be initialized with an integer like answer or answer number. So if I want to pass in arguments into my guessing game, what method do I need to leverage or use if I want my guessing game to accept arguments? That'd be the dunder init. So if I want to pass arguments into my guessing game, I don't even need this here. I don't know why that's always there, but I'm going to have this self dot answer number. That's what it's asking. I can call answer or answer number. So, and this is going to be self dot answer number equals answer number. All right. There we go. And I need two instance method, an instance method called guess. All right, which takes in an integer called user guess. So def guess always takes in the self keyword and user guess. And I'm just going to pass right now. I'm going to have to probably do some logic in here. Don't know what that looks like yet. Guess should return a string of high, correct, or low. So in here, I can say if user guess equals self dot answer number, I can return correct. If user guess is lower than self dot answer number, I can return a string of low. I think else, if it's not lower than it, and it's not the exact, if it's not correct, then it just return high. Is that correct? So let's run that. All right. So I've got this guess. So it's ran 3. All right. When a user guess 40, it should return correct. So this is where it might have been beneficial to break these out into their own unit tests, because technically part of this is correct. So if I were to comment these out, uh-oh, what happened? 20. Where are we going? Type error. When a user guesses.
I had to convert the user guess to an integer, so just int.
Hey, Tom, I think you're missing an underscore on the init method.
Oh,
there.
yep. Thank you. Thank you, Ankur. Let's run that. So see, now it's correct. But if I add these, it probably should be their own unit test, but I just kind of want to see what that looked like. So now I need this solve to work. So I need to create a solved, which returns true if the most recent user guess was correct or false. There's multiple ways we can do that. I think yesterday Ankur had like self.user guessed number and stored the number in here, and it initially was 0, and then stored the user guess in here. I'm going to do it differently. There's a bunch of different ways you can solve it. I'm just going to say is solved, and it's going to be initial value is false. And in here, I'm just going to say if, I guess I can just do it here. Once it used the user guess is correct, I can just say self.isSolved equals true. So if the user guess is correct, I'm changing this instance variable is solved that was initially false. I'm changing it to true if they guess the correct answer. So I'm going to create a method called, I think it's solved. Let's look at the documentation. Solved. And this is an instance method. It doesn't take in any arguments. And I'm just going to return self.isSolved, which will return a Boolean value, true or false. So if I clear the terminal and run my unit tests, they all pass now.
Tom, I just wanted to point out a little thing I learned yesterday. I was
Yep.
trying to use solved and as a variable and the method, and Python did not like that. It freaked out. So having is solved as the variable and solved as the method is a critical step that I learned the hard way.
Yep, I'm glad you mentioned that. Avoid having, or you can't have, you from naming conventions, you can't have instance variables or any variables named the same as your methods. So keep your methods naming separate from your variables. It's better just to be as descriptive as possible when you're naming your variables and your methods. So let's see. It said break down the problems into pseudocode, which I did not do, but I can go ahead and backtrack that. I can pseudocode. So I can initialize a class with an answer number instance variable that stores the answer. And also initializes an instance variable called is solved set to an initial value of false. And then like define an instance method called guess, which takes in an integer called user guess, and everything that I'm uppercasing are either like instance methods or instance variables. And then I can just do like if user guess equals answer number return, I could say reassign is solved instance variable to true and return string of correct. And I can do the same thing if user guess is less than. I'll just return string of low. Else if, else return a string of high. And then I can also define an instance method called solved, which takes in no arguments and returns is solved instance variable. Something like that. So that is the guessing game using TDD and backtracking to pseudocode. What questions do you have about how the guessing game was implemented using test-driven development, the setup method, or anything?
I just want to say that helps me a lot. Mine was structured like yours originally. Like Gonker had the solved before guess. It wasn't that different, but I think the self dot is solved equals false, and then making it true is what I was missing yesterday. So
Awesome.
yeah.
I'm glad it was helpful.